So the first question we need to ask is, how do we know when we see a graph out of a computer that shows us a polynomial crossing the x-axis that there's really a zero there? And as a secondary consideration, how can we find out where that is without looking at a graph out of a computer? In order to answer those questions, we have what's called the intermediate value theorem. And that tells us that if we have a continuous function, and a polynomial is an example of a continuous function, then if we have two numbers so that f of the first one is negative and f of the second one is positive, or the other way around, f of the first one is positive and then f of the second one is negative, then there's a number between those two that is a zero. What this theorem says is that if a continuous function changes signs, it has to pass through zero in between. In other words, if a computer draws that connected curve crossing the x-axis, it's justified in doing so. That function really does cross the x-axis in there. Now, this is begging the question, because I haven't told you what a continuous function is. Right now, continuous functions are ones for which we draw connected curves. But now this theorem says if we have a continuous function already, we're justified in drawing a connected curve. So this might seem circular, and at the moment it is. What is it about a function exactly that makes it continuous? Answering this question is our first task in calculus. When you take calculus, you'll meet this theorem again, and at the time it might feel like it's not really saying anything, because at that point you'll have spent a lot of time looking at these computer-generated graphs of connected curves, and you'll say, well, of course, that graph crosses the x-axis. Of course, there's a zero there. You're not going to prove this when you take calculus, because in order to actually prove this, we need to get down to some really deep questions like, what is a number anyway? So this is actually an incredibly interesting theorem, even though it seems to be saying something really elementary. For now, we don't have all the tools that we need to say what it means for a function to be continuous, but we do know that polynomial functions are always continuous. So let's look at that example we saw in the previous video. The intermediate value theorem shows us that this function really does in fact have a zero between 1 and 2. And to show that, we're just going to take, well, f of 1, that's 1 to the 5th, minus 3 times 1 squared, minus 1 is negative 3. F of 2 is 2 to the 5th, minus 3 times 2 squared, minus 1. That's a job for a calculator. That's positive 19. And I'm writing in the plus sign there just to emphasize that this is positive, because now we see f of 1 is negative, f of 2 is positive, and f is continuous because it's a polynomial. And so that tells us that there is a c between 1 and 2 that is a zero. So we've shown, using the intermediate value theorem, that that zero we saw on the graph, that was real. That really is there between 1 and 2. Now all that remains is to figure out, given a polynomial, how can we figure out where that zero actually is?